This is ME 2110. It's the Intro to Creative Engineering and Design at Georgia Tech. The point of the class is to teach us an intro to creative design, the tools we use to actually make something like this, to engineer a real machine. The cool part is that we get to build something.
All right, 3, 2, 1, go!
This is a tech startup competition. By creating this robot and having it do a bunch of tasks, we're having it emulate the creation of a startup company or .com or something in Silicon Valley, Google, you know, that kind of thing. So what we're doing is we have metaphorical tasks that represent the different things required to start a company.
So first, the government contract is with the lever or the button we push. It's worth 25 points. And then we have 2 sponges we have to get, which are each 10 points. The gate we lift up is another 10 points. The trucks that we push into the center console is 15 points each. And the squash balls that we drop into the cylinders are 10 points each if they're on the outer cylinders and 5 points each if they're right in the middle.
What this does is it uses essentially a spinning arm, and as the pipe rotates past it, it pushes this thing open, releases squash balls, and invests our funds, thereby securing maximum points.
So many hours of work. Most of us haven't gotten a lot of sleep the last few days, even though, you know, we've been on top of it. We've been doing stuff like not last minute.
So some of the challenges were that the majority of things we made just didn't work at first. So basically, instead of trying to fix those to make them work, we kept on considering our options, and we would reevaluate and rebuild completely. So I would say after this entire thing, we could have built 3 full devices.
This is actually our second iteration of this machine. First iteration, we had sidewalls. We ended up having a lot of issues with accessibility, so setting it all back up and getting down in there and pumping up the tank and all of that, as well as some warping of the boards going down. It just caused us a lot of grief. So what we ended up doing is taking our same concepts and applying it to kind of an open design, and then just ensuring that this open design fit within those dimensions.
The judges are really curious about what we think makes our design unique or superior in certain ways, which makes a lot of sense. There's a lot of course, everybody's doing the same tasks, so there's going to be a lot of overlap between what you do, and it seems like a really important part of what we're doing is taking all these ideas that everybody has and trying to put them all together into a very clean and well-performing machine.
As a judge, I'm looking for the aesthetics of the machine. I'm looking to see if everybody in the team is participating and if everybody in the team went through the process of solving a problem and then contributed to the effort. Thus far, I've been very intrigued in watching how each of these groups have come up with a unique solution to solve the set of challenges they were given. I'm very impressed with the teamwork that I've seen, and I'm naturally being a tech graduate, I'm impressed to see tech students are still very solid, and the school's in good hands if these students continue on the path they're on to graduate when they finish their time here at Tech.